Hi, good morning. I hope I'm audible. Uh, could if I'm audible, could you please type there? Okay, thank you. So, good morning, everyone, and welcome to today's webinar. Today's webinar will be about advanced lighting control solution with iNELS, and we will be discussing uh, what are the types of lighting control options we are options available in the iNELS system. Today's webinar will be running about 30 minutes, so we will be covering everything, not in detail, but I will cover all the topics. And there will be a recording coming after this webinar. So if you are not able to complete this webinar fully, you will be getting this video recording link after this webinar. So let's get started. I would also like to confirm that the slide is also visible to you. Okay. So lighting control within a building automation system offers numerous advantages which improve energy efficiency, user convenience, and overall building performance. So there are several key advantages which is necessary to have a lighting control system in a building. First of all, it is, of course, energy efficiency and cost saving. As you know that many of these buildings, if you consider a large building, then there are corridors, there are a lot of common areas which may not need lighting all the time. So it need only lighting when when there is some occupancy or when there is some movement. So using our system, we can do various kind of automation which trigger the lights when there is occupancy, which will eventually save energy, and it will give you more efficiency to the building. There are several ways which we can do energy efficiency or energy saving. We can do dimming. We can do automation based on occupancy sensor. We can do scheduling. We can also do automation based on the demand response capabilities. Next, it will give you enhanced comfort and convenience. Of course, we can create different kind of scenes, mood lighting, and so on, which will create more comfort and convenience. And also, this webinar is focusing more on advanced lighting control. So there is another feature called ambient lighting control, which we can also do with our system. So which will also result in enhancing the comfort of the people who are living inside the building. Also, we can do improve productivity and well-being using this lighting control solution. One of the example is that we can do tunable lighting, or it is also called as ambient lighting, which is usually used in offices. So in the morning, we can use for more productivity cool lighting, and then it goes to the afternoon or evening. Then this lighting will be controlled based on the lux level, which will focus more on productivity in the morning and maybe relaxation in the evening. So we can do different kind of scenario setups with the automation system within us. And then overall, we can do centralized management and control using our system without any extra hardware. This will cover in the last section. So with these key features, why you have to choose iNELS for your lighting control? Yeah. So there are several advantages with iNELS system. If you are choosing a lighting control system, we can offer numerous advantages compared to other systems. We have wireless and bus solution. You already know that we have a wireless, we have bus, and in wireless solution we have all type of dimming solution. That means different type of dimming loads which is available in wireless and bus. In both the system, we have actuators and controllers to control 0 to 10 volt, DALI, universal dimming, and all these options. And we can also personalize different type of scenes in wireless as well as bus. Also, we can do time-based control, ambient lighting, different kind of automation logics using the IDM in bus system, and also the rule engine in the wireless system. Energy management, we can do, we can automate or create rule with the motion sensors. And all these devices which is used in wireless system and bus system can be connected to centralized iNELS cloud platform, and you can control and monitor everything from there. And all these units are available in the mobile application for the remote control option. And there are wide range of integration possibilities with voice assistant for BMS system and so on. So these are the key advantages if you choose iNELS for your lighting control solution or project. Here you can see different type of controllers which we use for different lighting control types. First, we have a universal dimming, both for wireless and wired. Here I have used only a few devices because there are a lot of other devices which is available in our portfolio. So in the wireless, we have RFDEL71 for universal dimming. We also have a 6-channel dim rail option, which you can use for dimming dimmable type of incandescent lights, LED, halogen, and so on. We can ensure smooth dimming by selecting the proper light type in this actuators. And also in bus system, we have a DA366 where you can control universal dimming, and also you can adjust the smooth dimming, flickering, and everything using the device parameter settings in the IDM. And then we have DALI dimming, which is quite popular all over the world, which is a very cost-effective solution for lighting control. We have a central unit dedicated for this lighting control for DALI, which will drastically reduce your price for this lighting control solution, which can directly connect to the cloud and control and monitor everything. With this CU309 with DALI, you can connect up to 64 DALI ballast, and also you can do ambient lighting control with this central unit. We also have DALI in wireless, which is also unique in its kind. There is maximum 32 ballast you can connect and control through this RF DALI. You can also create scenes. You can also create groups using this DALI ballast addresses. And then we have 0 to 10 volt DALI dimming. 0 to 10 volt universal dimming in our portfolio. In the bus system, we have LBC. In wireless also we have controller, 0 to 10 volt analog controller. And also we have RGB control for bus and wireless. Sorry, there is a mixed image shown there. Actually, RF DALI image should become here. Sorry for this. So we have RF, RGB dimming in wireless as well as bus. So that means we can have all kind of daily dimming, all kind of dimming option available in the iNELS bus and wireless system. So next, I would like to show how we can do automation with our system for maximum efficiency. There are various automation we can do for different kind of use cases. So for energy management, usually in all the use cases, we use occupancy sensors, and also sometime for the outdoor lighting, we use time-based controller or uh, um, lux sensors. So after this, I can show you with the IDM how we can control different use cases with automation capabilities in the iNELS system. So with the occupancy sensor, we have different kind of occupancy sensors available in our portfolio, which is DMD3, microwave motion sensor MCD3, and PMS3, which is infrared ceiling mount sensors. So within the IDM, we can create different kind of logics. When the occupancy is there, then turn on the light, or if there is no occupancy there, then turn off the light after some delays time. And also we can automate different lighting groups based on some restrictions, which means if the door is open or if somebody opens the door, then turn on this light. And if something is open, then turn on the light. So these kind of restrictions we can add using the logics within the IDM and also in the cloud. And also we can do time-based control by creating schedules, both in the app. It can be created in the application for wireless and in the IDM for the bus. So I will share my screen for this IDM, and then we can go to the next slide. So I hope you can see my screen. So in the IDM, I have added CU39 daily with some devices for this lighting control. So I'm going to place it in the design plane. So I will also add, okay, we have one GSP 340 for control. Okay, so I will also add one sensor. Okay, so using this automation, when we go to the function, we can create a function when the movement is there, then turn on the output, analog on, and then if there is no movement, then we can do the delay off, or if you do just normal off, then it will off immediately. But if you give a delay off by some second, like 5 second or 10 second, we can turn off the slide without any further interruption, because this movement is like random, so it will give digital input like randomly, so it will like awful to switch on, switch off, switch on, switch off at some kind of time. So we can create our custom functions. I will create a function for this delay dimming. You can create your own time. So I choose it. So in this case, in this automation, we can do energy management using this motion detector, which will activate the relay or dimming group of lights when some motion is there. And we can also create some groups. So I will also create a group here. So in the group manager, we will create a group called analog group. So in the group, we will drag this group here, analog group, and then I can create lights from the group. And then I can also create another function to turn on the group of light. When it is on, analog group on, and when the movement is sorry. So we can create groups, we can create individual lights for this energy management option using this motion detector. Then we can also do, first of all, I show what are these logics which we can create in between inside this. If it is on, then you can also create more logics if this some condition is there, then turn on. So we can also create some light intensity if the light intensity is lesser than or greater than this value, 300 lux, then we can group on these lights. So we can do many automations, and I can also create another automation logic by AND or function. And we can also, instead of this key, we can also use if the actuator is, if the group is on, then we can then only it turned on this condition or by key. And here also you can do create bits or anything. So logics, there are unlimited logics which is available in the IDM for this kind of use cases. I hope it is clear. And then we can, so now you know how to create more automation logics within the functions. And then you can also create groups, and then you can create energy management using the motion detector. And then we can also create time-based conditions. So here in the system manager, if we go to system program, then you can see a two-state timing. So if I create, then I will, for example, I'm creating an evening light. So I can mark from which time to which time it should turn on and when it should turn off. So I mark here to turn it on. If I want to export, then I have to select it. And then in the design plane, I add it. I select it. So this time program will give a digital input when it is on. That means when it is 6 o'clock in the evening to 9 o'clock in the evening, this program will be turned on. So we can also create logics to turn on some group of lights. So I create another wire to this group, and when the program switch is on, group on, okay, and when it is off, group off. So we can create more time slots in a time scheduler. So I will also show you there. So this is one, and then if you want to add more timing for this evening, for the morning sometime, then you can also do that as well. You can do multiple time slots in this two states option. So when this time schedule program is turned on, we can also create logics to turn on these lights. So this is another way which we can control lighting automation in the iNELS system. Okay, so now I will go back to my presentation. Okay, next. We can do ambient lighting for enhanced comfort. So there are different ways which we can do ambient lighting control. So as I said, there are different use cases for it. First of all, let's talk about an office space which we can do ambient lighting control, which means in the morning, for the more productivity, we can do lighting control for some cool white, and then we can also adjust it for relaxation lighting. That means more warm lighting, depends on the time of the day, and also using the lux intensity sensor. So in the CU39 DALI, we have now implemented the new DT8 protocol, which we can do tunable LED. I will show you to you after this. So with that option, we can set different color of lighting in the project. It depends on the day or depends on the light intensity which we are calculating inside the office. So that is one case. And then the next case is like daylight harvesting. That means that is the option which we can do with light sensor. So within the change of lighting outside or the daylight, which we can adjust the lighting pattern inside the building. That is one case. And also we can do personalized lighting scenes with some morning scene, evening scene, or movie scene, and so on. So with these three options, we can improve the comfort of the users who is present inside the building. So I will share again my screen to how we can program it in a real life. Okay, so here I go to device manager, and this is U39, which has a DALI line. So I'm going to add an internal DALI line, and then I am adding a new DALI DMX unit. So for this ambient, this is the normal DALI unit, and this is for this ambient lighting control. That means amber white or tunable white. This is the different term which is often used in different regions. So I am adding this, and here we can set up the address of a two unit. For example, I am using 0 and 1. And if you expand it, there are two channels. One, this channel is for intensity, and the second channel is for temperature. That means the color changing, color temperature. So I am going to drag this to the design plane. So I use, okay, let us use different screen. So I use one icon for intensity and one for the color changing. And then I have light intensity sensor. And also I have a program. And yeah, so with this light intensity, we can, with this sensor, we can set some value to turn on these lights. That means if the sensor value change, then analog on or set analog bright to some value. We can do different set level. So if the light intensity is, light sensor measure some lower value, then we can set the light to the maximum percentage, and then you can set this light intensity restriction here. I think we have two light sensor. Okay, so the condition we can you can put it here. If the light intensity is lesser than or greater than some value, then you can turn on or turn off this light or set it to some percentage level. And here you can also do the same logic and to set the color to the maximum. So 100 means it is more warm, and 0 means more cool white. So this is how the color temperature goes. So this is how we can set it for the ambient lighting control for the offices or for some cafes or somewhere. There is also a function block available, lighting control for lighting control with 10 level. So I can show you that. So I select this one, and here I can select the light intensity sensor, and then we can also turn it through the digital inputs, bits or something, and then here we can choose the output, for example DA3, and yeah, we'll also, okay, now we don't have a system bit. After that we can connect it. And here if you see this wiring detail, you can see the logic is between the light intensity sensor to the output, and here you can see the different set level. So if the sensor value change, and if it is some value, then analog set level to the output. So there are different type of different 10 levels of condition we can put. So if the value is equal or lesser than 50, in that case we can do or more conditions. So here you can see there are 10 steps of lux we can set the output to the value. So here it is setting it to 100%, here it is setting to 90%, 80%, 70. So these are 10 step-by-step levels we can set the output based on the different values of the sensors. So same way you can also adjust the color of the color temperature. So this is basically for the ambient lighting control, and also we have use cases, or we had a big project in University of in Lebanon, I don't know which university, where we are controlling the greenhouse lighting. So, in the greenhouse, there is a specific kind of lighting, color, temperature needed. So we have used our DA303 there. I will add that as well. So based on the timing, we can set some color to this RGB for maintaining some this greenhouse, the color, setting the color for this RGB. There is specific kind of lighting which is needed for the plants to grow. So there we can set the event to turn on these LEDs when it is happen. Then we can mix the color automatically. Set level to 25. Set level to 75. Then set green to 25 and set blue to 50, and then this brightness to 100%. So this is how we can control uh, different kind of light settings for different kind of use cases. Next, I can show you different or how we can create scenes, personalized scenes for different kind of scenarios. So in the manager, we can create scenes through the system bits. So here I create a morning scene. Here I create evening scene, and we can also export this so that we can switch on or switch off this based on the sorry, you can switch on switch off the scene from the iNELS cloud application, from the iNELS mobile application, or from the third-party BMS system. So after creating the bits, we can create, we can drag that bits here. And we can select the morning and evening scene. And also we add some analog units. And we can create a function when the evening scene is on, output 1, this should be on, plus something from the RGB, green or blue should be turned on. Okay, so we can create scenes, we can create restrictions, we can create time-based or activation to switch on the scene. I will also show that. So if we have the to state, and then we can trigger this scene based on the timing. So this is how we can personalize different scenes. We can create different lights. There are no limitation for the lights to be in the scene. There is no limitation for creating the scene. We can trigger scene from the button. We can trigger scene from the time. We can trigger scene from the motion. Motion detector. We can trigger scene from the light intensity sensors. So the automation logics and the advanced lighting control, ambient lighting control feature can be set through different options or different ways from the IDM. So it depends on your use cases, how you can personalize your program based on your requirement. So I will go back to the presentation again. Yeah. So we can centrally control and monitor all the devices which is programmed in the bus system as well as in the wireless system through the iNELS cloud, which is centralized. So for example, if you have more than one building, or if you have to control more different sites together through the iNELS cloud, you can add all these central units to one iNELS account, and group control all these sites together uh, using the iNELS cloud feature. You can add more gateways to one cloud account, and you can control. You can distribute these cloud accounts with our user groups. So you can create different sub user account in the main cloud account, and you can assign some lights or some buildings to some users to control and monitor it. So and also you can after you add all these things in the cloud, you can also control it from the mobile application wherever you are. So iNELS offer free cloud connection and remote control options. There is also option to control it through the voice assistant. So once the gateway is connected to the cloud, and then if you go to the voice assistant platform like Google or Alexa, then you can add our skill in Alexa, and also support Google Assistant in the support device Google Assistant in the Google, where you can add iNELS account, and then all the units created in the iNELS account can be controlled through the voice assistants. Then finally, we can integrate with BMS system our wireless and bus solution. So the lighting control will be very easy and flexible using the iNELS system. So our gateways. Once you have all these actuators, dimming actuator, different kind of dimming actuators, then you can add all these actuators to a gateway, wireless or bus, and then that gateway can be connected to a MQTT protocol, and from there you can connect it to BMS system. And from the BMS system, it is possible to turn on, turn off all the scenarios which we created in the program. That means from the BMS system, you can control the Lex level, you can monitor how many lights are on, you can monitor the occupancy, and also you can trigger some scenes also from the BMS system. And with the help of these MQTT, you can integrate with different type of protocols using the BMS system. And also with our central unit, we can connect, or we can integrate with different protocols like DALI, like Modbus, and so on, which is very advantage for this BMS integration. So overall, with the iNELS system, we can do all kind of lighting control solution with wireless, with bus, with different type of dimming loads, different type of dimming loads, with different kind of use cases, time schedule, automation, energy saving, scenes, ambient lighting control, and everything. So this is all about today's webinar. I hope it is clear for you, and it is clear for you to use these information to implement in your project and use cases. So if you have any question, you can ask your question in the chat feature, or else we can conclude. Okay, Peter Chania is asking, how do I do if I only want to switch the lights on weekends and weekdays? In the bus system, we can only create this a time schedule throughout the week. But if you are using the iNELS wireless or application, you can select the time schedule in the app, and you can select the week or weekend days. In the bus, it is possible in the big CUs with the weekdays or weekend, but otherwise it is not possible. So you have to go through this cloud feature for activating this weekdays and weekends. Yes, Marius, thank you for your question. Yes, we are adding support for daily groups. Uh, I can share you my screen how we can do the daily groups here. Uh, so in this manager, there is a DALI manager. So I'm selecting the internal DALI master. Sorry, there is no CU connected, but anyway, I can show you how it is. And here you can search for the DALI. Yeah, since there is no ballast or there is no CU connected, I cannot show you. But once this you search this group like ballast, if it is a one ballast, then you can create a group here. First, you have to create group. So all those daily ballast, you have to select which group you want to use in. So I am going to add 0 to 1 daily address to group 1. So after I created or selected this group 1, I have to write the parameter. So it will be writing to the daily. And after that, we have to come here to the group, and you have to select. Okay, let me. I'm adding here 0, 1, 2, 3, and after that I choose lights for it, dimmable light. And I am assigning to that. So after that, I have to create a group. Same analog, I will create a daily group. And I have to select all the daily group which I created in the daily manager. You have to create a group here as well, and then you can control this group from the daily or from the button. It will make the daily group function or commands more faster. Okay, and then how can we configure daily lighting at Inspinia with CU39? Okay, so if you want to control these daily light through Inspinia, then in this device manager, you have to select this for export, and then select it for exporting, and select all the parameters in the third-party setting in the CU configuration, and connect to the MQTT broker, and then I will show you. Okay, I couldn't log in now because I don't know the password and it is the camera is on and it is not detecting me. But if you are into the Skype platform, you can add a DMX DALI unit there, and then you can choose the same um, MQTT uh, payload description and address, and then you can control it from the Inspinia. If you want, we can also public this document or video in the later days. Is there any other question? If it is clear, so I think we can wind up the section. Thank you all for joining the webinar and taking your valuable time out of your day, busy day. And I hope I have given enough explanation or enough details about the solution. And feel free to ask us if you have any questions or any features you want to add it to our system. You can contact us through support@elcoep.com or support@iNELS.com. Thank you and have a nice day.